All right, thank you very much for coming. It's great to have you guys here. My name is Michael Wong. Some of you guys may or may not know me. I see a lot of familiar faces in the room, and it's always great to have a talk in front of a group that I'm fairly familiar with. I'm the Canadian or the IBM C++ standard rep for the last 10, 12 years now, and I've gone through a lot of the iterations. I kind of wanted to play with this a little more because when people said, what, another standard, a new standard? Well, it's not C++11, it's C++14. And I kind of looked at it and I tried to create some sort of words with it. Herb Sutter actually helped me a lot with this when I was doing the native C++, Going Native C++ talk last year. So I took the idea of the fact that if C++11, we went down the rabbit hole with Alice and in Wonderland, that would make C++14 the follow on through the looking glass. And we played with some of the words to create some of the words, use some of the lines that Lewis Carroll made. So that's why I created this title. Now you also might be noticing that I also said no more raw food. And to be honest, now it's beginning to emerge certain types of programming styles from C++11 and 14. And some of that is going to be about, and of course, I'm sorry if some of you guys really love raw food. I do love a raw steak myself. Just to let John know, John is up here at the front, and we often go out for nice steak together. What I mean by no more raw food is that there are now a lot of things in C++ back in 03, like raw pointers and raw new and delete, that is now no longer necessary. And I like to use this, and I like to use this to expand on some of that, and maybe you guys can help me with some of these guidelines as well. I've been developing this talk. There's a version of this talk on video at Microsoft on Going Native. This is a much more developed talk because now we're actually we're now much closer to ratification. No talk like this can be done by one person. And as usual, I want to make sure that I give the right credit to the right people. So I always put this ahead on the front of my slide that I reference a lot of other people's work from the standard, from academia, from friends. Nevertheless, I want to make sure that you're clear that all the good stuff are mine and all the errors is someone else's. No, seriously. I claim credits for all the errors. They're all the stupid mistakes. They're mine. They're all mine. You can't have any of that. Okay. All right. So like I said, I did try to create a bit of a limerick. Limericks are a fairly well-known tradition in C++. There are actually 2 in there right now. How many people know what they are? Yes. Did you know what? They're there. You just know they're there. Do you know what they are? It's been a while since I've read them. All right. When writing a specialization. Thank you. Thank you. Thank you. Very good. What are the limericks? The one limerick is about the implosion on template specializations. Does anyone know? Was there another one as well? Does anyone know the second one? No? Okay, maybe it didn't make it in there. It was about that atomics can decay.
It made it and was taken out
by
someone who didn't like it.
So the time has come to talk of many things. And this is kind of an outline of my talk of move capture and literals and of making lambdas sing. And why deduction is so hard, and if digits should grow wings. And I kind of think of that because with digit separators, it almost looks like they're growing little wings on the side. And this talk, so this talk is going to cover some of probably the biggest feature in my opinion. Your opinion may differ. John has just issued his opinion. What I think are some of the biggest C++14 changes. So that is not just another bug fix release. There are substantial things in there to help you move forward. Just some look back as to where we are now. We're basically here. It's been 3 years since C++11. My God, it was only probably about 4 or 5 years ago I started coming to BoostCon before, and I started talking about memory models and atomics and things like that. And a lot of that has continue on. And now we're at C++14. The process is now somewhat compressed. Under the left column is what they call an international standard. And there are many more stages to it. It really doesn't matter what these are. Now there are these things called technical specifications. these TSs, they terminate a little bit earlier at the DTS stage, draft technical specification, whereas the ISs have these final draft international standards attached to them. And I'm going to tell you that what we're doing now with C++14 is we're actually conglomerating these together. Okay? And you're allowed to do this. Herb is great at this. I'm terrible at this. Apparently, if there's nobody made any noises or comments at this stage, I'll explain a little more what that might mean. And there's things about ballot periods and rules and things like that. I don't really want to talk too much about that because I do want to get into the technical part. You probably have seen this if you visited isocpp.org. And it's a kind of another timeline way of looking, focusing now specifically in this area where you can see a huge jam up of proposals moving forward. C++14 comes in here. This is in accordance with the idea what we call the bus train model. The fact that it wasn't that great that it took 10 years, maybe even more, for C++11 to come out. And part of that had to do with the fact that, and many of us in this room went through that. Part of that had to do with the fact that there was always one more feature you wanted to get in. Okay, there was always another new surprise that came out that we had to try to hold it back a little bit longer. That's not going to happen anymore because, in a way, we wanted to always have something in the pipeline, so that when the bus leaves, it loads up the bus and goes on. This is good for you as a user because I think you get more predictable standards coming out. There's C++11, 14, 17, 22. It's great as an implementer. I'm an implementer, and there are other implementers in this room, I'm glad to see, because now they can allocate resources properly. Okay? C++11 was a huge problem because it would take 5, 6 years to get it done. Now, if you know these things are coming, maybe it's a little easier. So you can see the pipeline is really full, and I'm going to explain a little more about what some of these guys are. This was in Issaquah. This was the approval photo by Chandler. I think 5 of the 7 national bodies have their hands up in here voting. Let me see. Recognize Biana's here. Is this in focus? Is this focus for you guys, more or less? Okay, cool. Let me see. Gabby, where are you? Can you tell me?
Gabby hat.
Yes, of course, the hat. Let me see. Who else is in this room?
Left second row.
Left second row. There you are. Thank you. And you? Where were you?
To the left, Herb. It's, it can just go up. Right above it.
Right there?
To the left, Herb.
This guy?
Down.
Down? Here?
Yeah.
Over here?
There.
Right there. There you go. Let's see. Anyone else in this picture from this room? Okay. Oh, there's me, of course, I guess. I should mention me. All right. So what did I mean by no more raw food? I'm not going to go through all these, but some of the things that are becoming evident as we've been going through these is, and I'm going to talk about some of these in this talk, is that no more raw numbers. Do type-rich programming. Things like don't declare, use auto whenever possible. Don't use raw null, or void *0, use null putter. Don't use raw new and delete. Use unique pointer and shared pointer. That's now in C++14. Don't use heap allocated arrays. Use std vector and std string, or the new VLA and dyn array. By the way, some of you guys may disagree with me on some of this stuff. Feel free to, because I want to enliven a good discussion about some of these. We can have that tonight, by the way. Go ahead.
Is that now on C++14 in generic, or is it not?
This is actually covering C++14 now. So the
Genary is temporarily in garage.
yeah, in the garage. So the question is this saying C++14? And the answer is, of course, some of these are not in C++14. Dyn array and VLA is now in their own separate TS, which I'll go into. Okay. Don't use functors, use lambdas. That's not a generic rule. There are times when a functor may still be useful. Okay. Don't use raw loops. Use STL algorithms, range-based for loops, and lambdas.
Should I use for each?
For each, thank you.
Should I use for each?
If you use, sometimes there are cases that it is quite useful to use for each, especially if you use for each with a lambda. Okay. And in fact, Microsoft PPL, I think, uses that a fair bit. This is a debate.
Before my time.
Yeah, this before my time. I know, it's before. The question was from Gabby, should I use for each? Okay. And the answer is yes, you should. This one I haven't quite settled on yet. The rule of 3, many of you guys in this audience should know what that is. Is it now the rule of 0 or is it the rule of 5?
I don't know, right? And that's included in your language. No?
You can get away with 0. Okay, so just some food for thought. I'm not going to answer all these questions in 1 hour and 15 minutes, but I want to enliven this discussion and give you guys food for thought for discussion tonight at the committee meeting. Plus, I actually don't know the answer to a lot of these questions, actually. I just pretend like I know some of the answers. All right, so what was going on when C++11 came out? Well, we certainly noticed we were missing a lot of fingers and toes. We were missing cbegin. It's the end. You can capture by copy or by reference, but you can't actually have a move capture in lambdas. We created user-defined literals. In fact, I was fortunate enough to be one of the lead authors in that proposal. But we supply no suffixes in any way whatsoever. What's up with that? Monomorphic lambdas, by any account, is a hit for many users as a way to supplant std_mine. But why did you stop there? I can tell you why, by the way, actually. We were in Kona, I think, and we had all the, by the way, polymorphic lambda was always in the proposal. Jaakko had it in his original paper. There was a point at which we kind of said, and this is another one of those bus train schedule versus, you know, the 2003 IS standard methodology was, we had to cut it off at some point. If we wanted to move it all the way to polymorphic lambdas, there was going to be a huge discussion on the syntax and in C++ standard true style, that actually, adding a little bit could actually derail the entire proposal. And so sometimes what happens at a standard level is you've got to cut it off so that you can at least give the core part a chance of passing.
Get accused of ignorance.
Yes. And then, of course, the big bike shed for C++14 was can and should we get digit separators? I know. We wasted far too much time in getting that. So if I were to look over C++14 and name some of them, not an exhaustive list, I would say fixes, well, relaxed cons expr, tuples. Is that really a fix, relaxed cons expr?
Yes.
Yeah, I kind of think, yeah. cbegin, cn, all the make XXX pairs. Shared and move iterator was in 11. We created unique and make reverse iterator. The features, generic lambdas, move capture lambdas and normal function deductions, digit separators. I still cringe every time I see that thing. Do we really need it? Binary literals, variable templates. In fact, I think we have one of the lead author here. So in fact, I'm going to have you explain to me. Heterogeneous lookup, quoted IO strings, and user-defined literal for time and complex. So if you want to leave now, because that's pretty much the rest of this talk, and you pretty much got everything in this talk now. I do still have to go through an exhaustive list because that's what the building of this talk is about. So I have gone through and literally went through and itemized every little change that I could pick out. I have a blog that goes through and talk about this in more detail. Binary literals, some of these I don't really need a big explanation or a big deal about how it looks. There was a consideration here about having a suffix for binary literal, okay, and using user-defined literals. That was blown out fairly quickly because when you look at the fact that we have octal hex as a prefix, it just didn't make a lot of sense for binary to be a suffix. So we thought putting it as a prefix makes a lot of good sense. Okay? And this doesn't prevented from also having some suffix as well too as a user-defined literal if you actually really wanted to. VLA came in, was mostly primarily a one-dimensional array as a kind of a replacement or a suggested way for people who wants to move from the C99 variable length array to this form. It's not a C99 VLA, which in my opinion is a huge abomination. In my opinion, this is VLA as it should have been. Okay. The difference, but after having done that, there was a direction to add a library version of variable length of this kinds of array. And that's along with Dynarray, which I'll point out later on, both of these were moved off to the array TS. And there's a little bit of history about that. For a while there, it was going to be in C++14. When Dynarray came about, people were somewhat surprised that it could actually live on the stack or the heap. And the implementation of that was that at that point such that we weren't entirely sure that this thing can be implemented efficiently. And given the fact that even though this is well defined and that Dynarray may have some implementation questions, and we went around that for quite a few hours at the standard level, it was decided it was one of the best things to do was to move it as a TS, as it should be, because there's still questions about the implementation and its usage. Now, why do we have two of these things? Why do we have arrays or runtime bound, which is what this thing is, this VLA replacement? It's called ARB, arrays or runtime bound. And why do we have Dynarray? And this is what my reading of what Biana wanted. He wanted people to move off gradually the C-style arrays and VLAs. And when the people do that, they would naturally migrate to the arrays or runtime bound, what this is. And over time, arrays or runtime bound still necessitate a certain kind of, style programming that you might not want to keep proliferating for a long time. And so eventually, I think the belief was that we want to move that to a Dynarray, which is truly an array, which is truly a library, C++ library version of this. That's why these two are kept together as one feature, more or less. It's one TS, okay? And in a way, that sort of works with the idea that we probably have more bugs from C-style arrays than anywhere else, than any other parts of C++. And this is a direct, deliberate approach to give people something that they can work with over time, okay? And move off the old abominations, that is VLA and C-style arrays. Do you want to add more to that? I don't know if I've covered. Thank you. Yes, sir.
What's the difference between C99 arrays with runtime bound and C++ 14 arrays, VLA arrays?
The question is, what's the difference? I think your question is, what's the difference between the C99 VLA and the C++ 14 array, the runtime bound? First of all, it's one-dimensional, ARBs. The C99 VLAs can actually be multiple dimensions, okay? And there are other subtle differences. When you actually implement, some of those array limits are actually L values or changeable, okay? That's where most of the abomination comes in, okay? That's why in the ARB, it was deliberately made such that it cannot be done in that way. It's only a one-dimensional way, when you can build on top of that if you really want to. Other differences? Okay, other differences from other people? Okay. All right, continuing on, I'm going to talk a lot more about normal functions, move capture. Biana noticed this. We pretty much took aggregate initialization as is from C. And during all that time, we've never really made a lot of changes to it. And Biana pointed out that aggregate initializations cannot be used if a class already have member initializers. Okay. And he provided this example. This is a fairly easy change in order to make this work. Okay. because there's just simply no reason why we can't. So the rules were relaxed essentially to allow member initializations in aggregate classes using pretty much the same rules as C++11. Right? I have a lot of material, but I'm happy to cut off at any point, but I usually do this. This is another big one. So there were a couple of minor ones. I'm going to hit the major ones. Relaxing cons expert functions. I really want to talk about that because one of the authors of that proposal is actually in this room. Were you? Oh no, sorry. You're not one of the authors, but you were one of the interested parties.
I was advisor, not. Richard,
So
did
Richard Smith did most of it. Yeah.
We just
Yeah.
make sure that everything.
So there was this proposal, 3597, I think, or 3598. Okay, and the whole idea was about relaxing the constraints on cons expert. There was a list of options, and we took one of them. I think it was option 2 or something like that. There were 2 parts to it. The second part is a little bit controversial. The first part is non-controversial. And what it was it essentially says, now you can allow declarations within cons expert functions other than static or thread local variables or uninitialized variables. You can now allow if and switch statements, okay, but not goto. Most of these make natural sense because these things don't fundamentally change the cons expert quality of that. You can allow certainly all the looping statements like for, including range base for, and do whiles. You can also have mutations of objects whose lifetime began within the constant expression evaluation. That's the non-controversial part. There was a little bit of controversy. I love talking about controversy because it does tell you that not everybody agrees with everything, and it's sometimes it's a very hard decision to make.
If I may add just to,
Yeah.
to say.
Please.
So the idea of cons expert essentially is you're doing some computation and nobody except the function knows that some variable is being assigned to or doing some other stuff. So as long as you are in computation and within the boundaries of the function, nothing is leaked out. Like you don't throw exception, you don't print out, then morally the result of the function is the constant, right? Because you actually have put into the environment and nothing else is leaked, and that will make it very difficult to reason about. Oh, when you use this as complex argument, oh, do I need to destroy here, or where should I print the message? So it was really a fix to what you had in C++11. What you had in C++11 is really constrained version of what you had.
Thank you. Now to the controversy. Did you know that cons expert non-static member functions were implicitly const? They are.
I'm guilty of that.
This implicit constness sometimes creates a problem for literal class types, which wants to be usable both within a constant expression and outside of them. Okay, so what we're talking about here is basically allowing more elaborate computations, and making them implicitly const prevents, I guess, what they would call mutation of data. So this is controversial because a lot of people some people feel that this wasn't really attacking the underlying problem. For instance, if you can recall, you can't actually bind a temporary to a non-const reference, but you can actually call a non-const member function. I think you were the one who showed me that. I thought that was cool. Let me just complete that. You can actually call on a non-const member function on a temporary of class type, just to complete that thought. So there is some ABI concerns here with variable mutation, and there's some chance that this is going to require code change. But the problem is that the longer we wait to fix this, the more code is going to be out there in the wild. Okay. Now, what was the resolution of this controversy? Did we choose to leave it so that the...
We just, no, we made it fixed because we're going to have what, 2 or 3 years in between the two standards.
Yeah.
And so we just decided, oh yeah, it's going to be ABI Brigade, but sorry.
Right, right. So in the meantime, you can actually say, you know, as a user, you can deal with it with a conscast, okay? Or add a qualifier like mutable, just like in lambda expressions, okay? All of these alternatives were essentially rejected, but not by much, if I remember. I took a look at the vote. Let me see. I'm going to talk a little bit about a lot of these other things. Cons expert. Yes, sir. Go ahead. Question. Yeah. The question is, why can we not have cons expert lambdas? Do you want to take that? No.
So, every time something with lambda comes and people are always like, oh, is it going too far? Right? There's always these unknown things. And for example, one thing that people would have liked was that you could, there's a thing we call literal type, essentially a class type that doesn't usually surprise. And people wanted to have lambda type, you know, comparison a class type once that type as a literal type. And not all compiler vendors were aware of that. So context for, yeah, we should be able to have context for the next thing is, usually the way we have context for is you put the keywords in front of the definition. Now where does that go? Just before you write the lambda or at the end?
If I create it in C++, well,
Right.
if I write a const expert function and there's a lambda in it, well,
Yeah, because lambda itself is not a context for and does not use the literal type, which is what the compiler vendors didn't agree.
Yeah. It doesn't. It's not a literal type. The lambda. It's its own type, which changes all the time every time you invoke it. Right.
just because I'm really interested.
Yeah, sure.
Yeah. We can discuss more about that and see if we can come to some sort of a proposal or paper. Yeah. Yeah, I know. It might be a convincing one that we can bring to in front of the committee.
Yeah, the plaintiff proposal might be well received or.
Well, so this thing that the lambda type, the class type for a lambda cannot be literal type was a decision that was made from core. Right? And if you want to make change that, don't go to core, go to evolution.
Yeah, you have to, it would require fundamental change at this point to
And
change
you might
lambda
have better chance.
to be a literal type.
Core by definition is more conservative.
Yeah.
If you feel like they have to change something, you will go to the default conservative change. If you feel that you have use cases, competing use cases, then I would encourage you to write paper for evolution. That's where you get all the crazy people. So they all say what, and they don't care for it.
Yeah.
Core has to fix it.
So that's why I'm saying we should discuss this. If you're really interested in it, I really encourage us to write a paper. I will help you. Okay. There are use cases, and I recognize them. Okay. You're welcome. This is interesting. It's a proposal to support cons expert template variables. So what it does is this replaces the use of static data members for parameterized constants because they're kind of annoying. They have this kind of annoying thing where you have to do duplicate declarations once inside the class template and then once outside the class template to give the real definition, right? You've all seen it, in case the constants is ODR used. So here's one example using a poly matrix used in quantum mechanics to define these constants, templatized, okay, so that it can be updated. Like I said, I want to get through a lot of these. I don't want to go through too many of these because I want to get to the point of this. There were a large number of C++14 library changes. The biggest, the one that I'm highlighting here is the tuples. You can now address tuples by type as opposed to just by position. Okay. The 14, there are more. Now you can actually. So here's what are all the changes for make unique and the UDL suffixes and the user-defined literals for complex. We also removed getS. Okay. And there's always a whole bunch of things that's coming in trying to cons the standard library, and that's always standard stuff that's constantly coming in. The quoted string one is kind of cool because now you can actually have a way of keeping the original quoted strings as opposed to having it separate out the original, separating out the string. I'll leave this in the slides so you can study it. What else? Heterogeneous comparison lookups. Optional started life inside the as a library change. It too was moved to library fundamental TS. There were a little bit of controversy here because some people felt that not every operator was supported in the proposal for optional. Okay, and because of that, you know, generally if there's not enough consensus and if something like this lowers the amount of consensus, you move it off of TS, try some implementation, get some reference ideas before you standardize something like that. Okay. I live mostly in concurrency, and there were a number of concurrency proposals. Most of it has to do with fixes that we've been trying to make things smoother. Shared mutex has been renamed to shared time mutex because it has a chrono element in it. All the other ones are actually called time something, time recursive mutex. This one got left out as. Now the one thing to be aware of is that the original author, Howard Hinnon, did not like this change. He wanted to keep it as shared mutex as opposed to shared time mutex. I can't really explain what the whole reason is, but nevertheless we did change it. This is having to do with the next one is having to do with the fact that there was too much prohibition in the memory model about the interaction between atomics inside of a signal handler. They are allowed if we can sort of define what those are. So this is just a relaxation of that. Lock-free, for those of you guys who love memory model, and I'm one of those, what it has to do with the fact is that in memory model theory, and the standard says lock-free everywhere. The problem is that when it says lock-free, it's not really lock-free. It's actually obstruction-free. It actually says that in the presence of fair scheduling, in other words, you have two threads competing for a resource, one of them will actually always make progress. That's called obstruction-free. And PowerPC, where I live, which is IBM systems, are actually obstruction-free. Okay? The other world, where if you have a single thread, then yes, you can say that obstruction-free can break down into lock-free. Okay? That's kind of what most of the standard tends to talk about. And this is just a way of making sure that that's now clear, that what lock-free means, what obstruction-free mean, in the presence of what we call fair scheduling. Okay? Another PowerPC prohibition about out-of-fair results. I don't want to go through too many of these again because once I start talking memory model, you can't shut me up anymore. So let's just say that a lot of these are just good things to do to patch up the memory model. Let's go to what's available in the future. So up till now, I've only talked about what's in C++14. Let me talk about what's coming in the future. These are the things that are coming in the future, other than minus the top part, which is its own international standard. Every one of these on technical specifications in flight. This one is going the furthest. In fact, this one is most likely going to get to a DTS by either the next meeting or the following meeting, actually. Okay. All of these other ones, Library Fundamental has a large set of changes now, including optional and other fundamental utilities, as I said. Networking TS are now being pushed into the library TS, their proposals. Concept TS, what you just heard in that excellent keynote we had talked about, is talking about an extension for template type checking, concept light. Okay? That TS has now been started. Actually, it was started a while ago. It's now had additional material injected in, from which a basis of the paper can be drawn in the next meeting. Array TS has to do with the ARB and the DynArray that I talked about, and those are now in flight. In the concurrency group, we started 2 TSs, Parallelism TS and Concurrency TS. Parallelism TS is all about the idea of supporting parallel algorithms. One of the things I said when we had a parallelism summit in Microsoft in May 2012 was that we need to parallelize STL. There's been tremendous effort going on with that. Previously, people have used OpenMP, pthreads, other kinds of Win32 threads. Well, this is one proposal that came out of a joint work between Microsoft and NVIDIA and Intel, where the idea is now STL algorithms like sort can now take a parameter, I think it's the first one, where you can say std sequence, SEQ, to say that it's sequentially executed, like what we do today. You can say std par to say that it's in parallel, it's going to be run in parallel. And it'll select the parallel algorithm. You can also say seqvec to say that it's vectorized and parallelized. Okay? And there's provision for you to add things like support for accelerators and GPU accesses as well. There was a great deal of discussion about whether we should create totally different names or the same name. We ended up going with the same name, just for the sake of it. I can't recall what the winning argument. In many of these cases, it probably doesn't really matter all that much. The concurrency TS is supporting 2 proposals. One is the Google executors, which is a way of parceling out small tasks, okay, so that they can be executed concurrently as a non-blocking extension. And the other one is the Microsoft style of concurrency, which is in their Windows code everywhere. It's called futures. It's a much more extensive form of what the current futures, async future gives you. It adds things like being able to do await, okay, being able to join multiple futures together. Okay, right now the current stuff that we have cannot do any of that stuff. So this is a significant addition. And there's going to be more stuff like that in terms of concurrent hash tables and latches. These are all kinds of things that is going to be very interesting and useful if you work in anything that has to deal with atomics, financial, okay, high speed, so that you don't have any kind of weight. This is where I love to live, because this is the kind of things that will take C++ to a much more standard way of dealing with these. Right now, it's kind of in the wild right now. There's like pthreads, there's OpenMP, there's all kinds of different ways of doing things. Okay, I'm chairing this committee called Transactional Memory, which takes it even a further step. This is the idea that if you're dealing with mutable shared states, like locks and things like locking global data, okay, I'm offering a way to do it so that it's composable, okay, and it has the same performance characteristic as fine-grained locks, which is not composable. And composability, in my view, is so critical because C++ is all about composability. The fact that we count on calling libraries, all of that stuff breaks with C++ if you use any kinds of locks. Because they just don't compose. They will easily cause deadlocks. It's only a matter of time. So that's what I'm working on. It's the only reason why I highlighted it in red, by the way. All right, what else is there? I need to explain what the library fundamental TS is about. The only thing I was going to point out was that optional is here. All the networking byte order is now here. Faster string searches, that's a big improvement using this new algorithm. String view is interesting because it is, so the strings that you're familiar with is a normal C++ standard library strings, which is a class wrapped around an actual reference to a string object, which can be implemented using either a pointer, or it could be implemented as what's called short string optimization. And what that means is that if the string is small enough, it's actually kept in memory inside that class. And as soon as it grows too big, then it goes to a reference. String view is actually the dereference version of that string. Okay? So that what you actually get is an actual string. The string class, what you get is not a string, it's a class. It's a string class. And there was a great deal of discussion, actually, about where to put this, because later on when we started talking about user-defined literals, because people wanted to know whether S should be a string, as we have it today, a class, or should it be the true string view. Okay? It ended up being the class. The question?
I'm a bit confused now.
Mm-hmm.
View suggests
It's a view.
Data structure.
Right.
It's an observant piece that sits and points into other data. And maybe has an interface similar to string so that it allows all the operations as well.
Mm-hmm.
But so you said it's the actual string. String view is the actual string. What do you mean by
I'm going to take your words for it, actually. So you're saying that the string view is a view that can reference into other things. Okay. That's what the question was. I'm going to take your word for it at this moment. I'll check up on it. Okay. Because I haven't really read enough of it. I was involved in some of the discussion.
It's previously called string ref, and isn't this exactly?
This is exactly string ref.
So what it's trying to do is
Yeah.
to allow one interface to take either a constant store or a std string.
Or std string.
And this makes that the vocabulary type. That's
Right, right. It is string ref, actually.
it. And there you go.
Okay, yes, go ahead.
As far as I remember the proposal, it's basically a constant interface of std string and it references to some Boolean string or something.
Right, okay.
It doesn't
Let me see. I'm getting eating through my time fairly quickly. Concurrency, where are we going with it? The parallelism has already started at TS, of course, with parallel algorithm. We're going to start adding more stuff to it, depending on which one of these is going to be successful. Vector SIMD, there's some issue with that because the language isn't very C++-like. Task-based parallelism with Silk, OpenMP, fork join. I'm involved with a lot of these things. MapReduce, Google's MapReduce, and pipelines. Concurrency, what are we looking at for the TS? Now we're adding, of course, the future extensions for then, wait any, wait for all. Okay, as I said before. Google executors. And coming in behind that will be things like resumable functions, await, counters, queues, concurrent vectors, unordered associative containers. The difficulty with this one is how to do lock-free concurrent erasure. And there are multiple algorithms to do that. Hazard pointers is one of them. Okay. Latches and barriers and upgradable locks are some of the other things that's in flight right now for concurrency. Okay. This is just a more detailed discussion of some of these, and I'm not going to go through it. All right, so let me see. So the C++ programming language is at the this stage. So going into the June meeting, library, array, parallelism, TS are going to be in the PDTS stage. Okay, and then the concurrency will also be in that. File system, as I said, looks like they're going to go to a draft technicals. This is their final stage where they can actually be voted out as an official TS in the June meeting. Networking, most of that is falling into library fundamental. We just started a new work item in the last meeting, and we're looking at either going to PDTS here or maybe later. Okay, concept light, okay, is going into PDTS. Most of these who are in PDTS started as a new proposal back here somewhere, and now they are looking at going to PDTS and potentially DTS as we go along. Some of these dates are going to slip by maybe one more meeting, and that's normal because it all depends on how much work gets done. Okay. Feature testing recommendation, I have to talk about that. There is a group that has been talking about how to do these feature test macros. Okay. Clark Nelson led that group. And the idea is that because there's always going to be ongoing feature injection into the standard, we're not going to legislate it as part of normative wording. It's going to be a live, ongoing document which is going to be a recommendation for compiler vendors. And as far as I know, pretty much all compiler vendors are going to go with this to create this feature testing macro facility. So it's going to stay live here, and it won't go through any processes about getting through as a TS or anything like that. There are two more groups, though. There are a couple of more groups, though. SG2G2 modules is talking about a way of a compilation system using, I believe, namespaces and private and public in order to create a sort of a faster compilation system for C++. There has been some work, not a great deal, so that's why you're not seeing a huge amount of action there. Numerics is talking about incorporating IEEE floating point into C++. I believe it is not part of C++, okay? As well as things like decimal floating points and things like that. Again, not a huge amount of action. Reflection is about bringing to C++ compile time reflection as opposed to the dynamic runtime reflections that we have right now using RTTI. I have absolutely no idea what ranges is. I think, let me take a shot at it. I think it's trying to create new kinds of ranges beyond iterators. I remember an excellent talk by Andre Alexandrescu, it's here, where he says, iterators must go. He was trying to highlight the fact that there was a lot of other kinds of iterator ranges. I think one was circular, that we don't support at all. I believe this is what it is. Again, I don't know much about it. I can't say much because there hasn't been much action in the group, and I can't really latch onto anything. Okay. Undefined behavior. Oh, before I get to that, database has become inactive. There's need to have a sort of a standardized SQL interface, for instance. But the lead of that is now resigning, Bill Seymour, and they're looking for someone new to lead something like that. Undefined behavior, SG12. The lead is here. I'm going to have him describe this. Oh, I have a meeting. I got to go. Yes, I know. You can never be tethered far enough from the office. I'm going to disconnect the office. There's a lot of undefined behaviors in C++, in the C++ standard, actually. And I think one of the goals, and I'm hoping Gabi will jump in, is to either reduce that set and name it and add other ones that makes more sense. Is that what have you guys come up with things that are?
Well, yeah. So we have been discussing things in some cases because you can take the standard and search for different behaviors. You'll find about 180 Nicol language, but it doesn't give you a set, right? Because sometimes the standard says, "Oh, you shall not do this, comma, no diagnostic required," which essentially means go back and do it, which is the same thing as undefined behavior. And there are a bunch of other stuff. Some of the restrictions make sense. Right? Others just us not being rigorous, and some are controversial. Like you like your compiler to start checking your integer arithmetic. Some folks would say, yeah, of course. Others say, no, I really want to get the performance from the hardware because that's what I'm doing. So we do need to make progress on those issues.
Okay.
Things are being proposed.
Yeah. Thank you. There's
one more thing.
yeah. Go ahead.
Today, as of today, you can get undefined behavior from the preprocessor. There is no reason for it.
Oh my God.
There's
Oh my
no
God.
reason for it. That's just we, the standards committee, being lazy. Hopefully that will fix soon.
Thank you. That's good. One more group, I/O. It says I/O, but it's actually about graphics. And it's a group that is started by Herb Sutter to work on adding graphics to support in C++. Now, there's a lot of graphics contenders out there. There's Qt, XAML, okay? In fact, Microsoft struggles with that a lot, as I understand it. And this is, in fact, I just came from a Microsoft sponsored meeting in Munich, actually, ADC++. And every question was about XAML. That was what Tariq is there. Yeah, and I was there. So One of you guys should go instead. They keep asking me to go. I don't know why they kept sending an IBM person. Yes.
I'm a GUI guy.
Good, good, good. Yeah.
Yeah. So that's very interesting. to
Yeah.
me.
Uh-huh.
So the proposal is to potentially put GUI type operations, dialect box, and all that crap over into the basic language.
I'll take this.
Thank
one
you.
here.
Thank you.
So, going native 2012, Herb showed, said, you know, gave a contest basically to go out and create something as streamlined as possible that using existing, I guess, there was some nice programs done. He showed off on PacMan like, and from that, this study group was created. In Chicago, was the first meeting, in videos there for people. We discussed whether or not it should include things like the Blues graphics library to deal with more geometry. No. Should it be widgets for GUI? No. Should it be OpenGL DirectX? No. What they're looking at here is something beyond VT100.
VT100,
Text mode.
Texmo VT100. ASCII art, otherwise known as.
So, a graphical console, basically.
Mhm.
And so that's why the name changed from graphics to IO.
Okay. Are you heavily involved in that group, more or
I
less?
have been to 2 of the 3 meetings.
Okay, that's great. As you can see, it's impossible for me for one person that IBM sends to attend all of these meetings together. Plus, I'm chairing my own meeting. But I do my best in reviewing the notes and following up and talking to other people to help to. And I know that generally I'm asked to do these kinds of things where I talk about where this whole standard is going. So I try to keep up as best as I can. Where are the compilers? I want to thank Marshall for this. He just gave a talk at LLVM Conf, and I was there, and he kind of gave me all the key information. The rest I kind of abstracted out, you know. The percentage is a rough thing that it's my opinion. It's not really, there's no real bar measurements. C++ 11, Clang 3.3, language and library essentially was complete June 2013. And GCC 4.8.1, the language is complete, but the library I think is about 75% done, to be completed in 4.9, which by the way just GA'd actually weeks ago. There's a whole bunch of other compilers. Intel using the EDG front end and either a Microsoft or a GCC or Clang library. Okay, the numbers don't really mean much. Most of the other people are roughly about 75% ongoing. My compiler is also in the same way. We're a little further behind on the library. Microsoft, the language is roughly about 75% done when I look at it. You can go up or down by 10% there. The library is bought from Dinkomware, so it's essentially 100% done. Solaris came out and claimed they're completely supporting C++ 11, 12.4. I actually highly doubt that. So when I took a look at it, I think it's about 50% done. I'm not even sure of that. Sorry, Solaris, but I'm not really sure because I couldn't really tell. The fact is that they came out of nowhere with no previous actions, and I kind of have difficulty believing that it's all done in one release, but you never know.
IBM expectancy, you're from IBM, right?
I'm the senior compiler. I'm the senior technical lead.
That's the library done for IBM.
You see, I can actually answer lots of questions about what other companies are doing. I actually, because they're not going to fire me. I actually can't answer any actual questions about what my company is
Can you
doing.
actually just like throw a ball and get to the right quarter or year or decade?
Let me get back to you on that. C++ 14. You like that segue right away? Clang 3.5 says that the language and library is going to be done by Clang 3.5, which is supposed to come out because they just GA'd January, and now they just GA'd 3.4.1 days ago as a patch release. They don't often do this. Clang doesn't have a kind of a back patch type of a policy, unlike GCC. They claim that either June, July, August, depending on when they GA 3.5, which is in the trunk now, it will be there for C++ 14. Okay. GCC 4.9 plus later on will probably be the one that has C++ 14. Some of you guys might know a little more than I do. Thank you. and others will follow most likely with their favorite features, focusing specifically on that. Okay? Interesting, eh? I pretty much spend most of my time talking about this stuff, but I guess it is interesting stuff because people want to know about this. I'm going to spend the next 15 minutes that I have left talking about. I'll pick one of these. I'll try to do at least two. I actually was going to do literals, lambdas, deductions, digits, and move capture. So I'm going to do literals for now, and maybe lambdas, and see how far I get through, okay? So, you guys have all probably heard of some of this stuff. In 1983, this plane called the Gimli glider, a Boeing 767, ran out of fuel and landed in Gimli, Manitoba, looking like this. Miraculously, no one died. Later on, people were looking at it trying to figure out how is it that a modern jumbo jet like that can actually run out of fuel. And it was a simple matter that there was a unit conversion problem. Okay. Instead of 22,300 kilograms of fuel, they had 22,300 pounds, which is actually 10,000 kilograms roughly. Air Canada had just switched to metric in that particular month. And people were trying to hand calculate all this stuff. I know you chuckle now and you go, God, I can't believe that happened. I hope I'm not on that flight. Thankfully, nobody died. This was an airfield which was at that time converted into some sort of picnic. And there was a whole bunch of people having picnic, and they all had to scramble out of the way as this plane came tumbling in to try to make a landing. Go Google Wikipedia this, and you'll love the story. Or go look at Air Crash Investigation, one of my favorite TV shows. You get great reviews on that stuff. You think this wouldn't happen again, but in 1999, September 23rd, the Mars Climate Orbiter, costing something like $650 million was lost due to something very similar. It was a software error that didn't use metric units in the ground software. The thruster performance data was calculated in imperial units. The loss, here in this case was just one flight. Here in this case is almost incalculable. The lifetime of 200 engineers. No mission scientific results could be obtained because of that. The orbiter crashed, by the way. It didn't land where it's supposed to. And this is something that we were all taught since high school about verifying units. Okay? And the question, of course, comes, why don't we have units in mainstream programming? We don't. We don't because of some weird reasons. Some of it has to do with the fact that no mainstream programming language wants to keep units constantly hanging around because they cost memory, takes up space. Okay? They always think that this is the job left to the comment, okay, or something that's in the data that's to be kept. Keeping this unit just think about it, keeping this unit calculation carried along essentially doubles the size of your data every step along the way. And that's just not, and it also involves checking in every computation. All these things, space probes, airplanes, cell phones, all have extraordinary memory limits. They were small. They were 64 kilobytes back then when I was in school. Even though they're massive now, they still have memory limits. You'd much rather be using that memory for doing something else, right? You all know that if these numbers cross an interface without the attending unit programming coming along, it totally changes the meaning. Here in the orbiter case, it changes by 4.5. Okay? And I've talked a little bit about why general purpose language programmings don't support that. And it was precisely because of all these things that I with a bunch of people, decided to invent C++11 unit programming. Okay? And the way to do that is now done through the C++11 user-defined literals. And this is something that Beyonder is coining called type-rich programming. Instead of passing raw numbers back and forth, keep it type-rich. Keep the types with the number. Now, up till now, it would cause space and time, and as I pointed out before. With literals, it's not as much of a case, right? So my original motivation for inventing user-defined literal was to address the fact that literals, classes could be user-defined classes, but you never have user-defined literals. Literals by default, up till this point, before C++, was always one kind. It's known as, in the computer language parlance, was called 2's complement. Okay? They're not even decimal based. C decided to fix that problem for most financial community. They actually want calculations in decimal, your bank accounts, so that little numbers don't fall out like Superman. I'm not really sure that's actually true, but whether you can, whether you can get rich by collecting all those little numbers. But so they decided to create something called decimal floating point literal, so that the calculation is in base 10, not in base 2 that computers like. The problem with the C extension was that if you bring it to C++, which they did, there is a technical report called decimal floating point literal, which we're going to try to put into the numerics TS, by the way, was that you can't initialize these things. There are no base 10 literals in C++, so you can initialize these decimal floating point literals with. How do you, well, the only way you could initialize them was to call these bunch of constructors on it, okay? So given looking at that and looking at the need for unit programming, we decided to create a syntax to allow you to define any kind of literals that you feel you would want, okay? We enhanced the capability so that it can be done in an embedded programming way, so that it can be all done in compile time. Now, as with anything in C++, when you put something like this in, now looking back, I can see that the syntax is somewhat, it's not the best in the world. It's hacky, okay? But it is there. So I'm going to go through a little bit of quick look at this user-defined literal suffix, okay? So the idea is that you want to be able to say the kind of suffix you want to the literal, and the compiler would go off and do something with that and convert that number to the actual quantity that you care about, okay? So UDL, what we call user-defined literal, is just an unqualified call. And the way we did it was that we just made it as a syntactic sugar, so that it's just when you have a suffix like this, it's just an unqualified call to an operator suffix with this double quote in front of it to identify the fact that it's just a call to this thing. Underneath, this is just expanded to this. You could write this completely on yourself if you really want to. Now, to make it work, we had to do a few things to the language. This is the fundamental syntax. You have something that you have to create this thing called the X operator double quote suffix with parameters, where X is an arbitrary return type, and the suffix is an identifier literal suffix mapping to this call, and the parameter we're going to describe later. Now, some deficiencies here. Can it handle prefixes or both prefix suffixes? No, this is just suffix, okay? Was any user-defined literal in C++? No. In C++ 11, no, but in C++ 14, yes, okay? Now, for the users, you can do this too. You can create user-defined literal. But because you don't actually have control of the system, you have to put underscore in front of them. Okay? So you have to say 3.2 underscore kilometers. Now with C++ 14, which we didn't put SI distance in yet. We have put chrono times in. Okay? So you can actually drop the underscore because the system is allowed to, the library system, the C++ library system is allowed to not have the underscore. So this user-defined literal, because it's got this underscore, is just a call to this operator, double quote, underscore kilometer. The underscore is part of this suffix, with passing in 32.5 long, okay? And all it is just a call to this expanded form, this const expert operator, double quote kilometer, long double distance. Now, the reason it's always going to be long double is because no matter what it is you pass in, the fundamental type that C++ keeps is always going to be a long double, okay? So you can do all these things, and it's pretty cool. You can do assign it as a kilometer. You can convert it inside the operation function, so you pass in underscore miles. Whatever it is that you call underscore miles, it can return a kilometer out of it, okay? You can mix built-in strings, literals, user-defined literals, okay? Now, the thing to know is that with user-defined literal, there are actually two groups. There's the raw group and there's the cooked literals. Now, we designed this for two reasons. for most part, you actually only care about using the cooked group, using the cooked literal. And that is because the way the C++ literals work is when they come in as the raw digits themselves, okay, they're usually cooked by the preprocessor, by the various phases of translation. So they already carry a specific meaning to them. Okay? They have a length, you know how long they are, you know how many digits they are. Okay? And with this, it's fairly easy to convert into these kinds of, where you just want to do conversions for kilometers, miles, and things like that. It's already in that form that you would want. Okay? Questions? I think, sorry, yeah.
If there's no conversion,
Yeah,
for example, from kilometers to seconds,
yeah.
and you try and add them or something like that, you're
Mm-hmm.
gonna get an exception? Or can you define an exception or a?
You can define an exception, yeah,
Okay,
yeah,
okay.
yeah. You had a question?
Yeah, I was wondering.
So the question was, is it possible to throw an exception from inside during conversions? And yes, you can, okay? And yours question?
So yeah, one follow-up question on this one first. So it's not the compile time.
This form is not, so the question is this form the compile time version? No, the cooked ones are not compile time versions. The raw form can be templatized using variadic template so that it can be compile time. If you need compile time, you got to go to the raw form. Okay.
So the second question I have is about ambiguities in the resolution. Say you have seconds, and seconds can be represented in doubles or nanoseconds or different types of granularities.
Yeah.
And that would be kind of something, would be similar to an illegal return type overloading.
Mhm.
Is there some sort of inference that can happen that the arithmetic that you do sometimes chooses the right type? Say this time for this computation it uses nanoseconds because it needs the precision, but for others it uses milliseconds.
But don't forget, so the question is, does the precision, because there are different kinds of positions, forces you to do overloading on it so that you have to define the overloading for the precision purposes. Is there some complicated ambiguity rules that you have to follow? The interesting thing is that the way we designed it, you actually don't have to do any of that stuff. It only accepts very, very basic parameter types, long double and unsigned, is it unsigned long or for the integer, for the other types. It doesn't accept anything else. And that's because that's how the compiler really sees these numbers. You can, when you output it for precision purposes, you can output it in whatever position you want. Now I'll show you what that means, okay?
So, what I'm puzzled about here is that, let's say I have seconds,
Yeah,
that converts to a long double.
yeah.
Then I have kilometers, that converts to a long double.
Mm-hmm.
There's no intrinsic reason why I can't add kilometers to seconds.
Mhm.
But I want to make sure that I can't do that.
That's
because
right.
Otherwise, I've got a programming error.
Because now you have to create the operator plus to define what you can actually add. There you go. The question was, sorry, do you have to repeat? Yeah.
Produces a different type in those two different situations.
Yes. Yeah. Thank you for that. So the question is, what if I want to enforce so that you can't add a mixed type so that you can avoid the whole problem that I was trying to illustrate? And the answer is, thank you for that. What's your name, by the way? Lisa, thank you. Actually, I think I know your name. They produce different types. And because of the different typeness, if you use if you supply the appropriate operator, then yes, you can do operations on them. If you don't supply it, you're not allowed to do operations on them. Pretty cool. I'll fly through some of this stuff, unfortunately. Okay, so the cooked literals. There's only the only thing that you can do with cooked literal, okay, is that they can take they always have to take things as a character, okay. Oh, sorry. Okay, there are only there are only a couple of things. They can take things as a character, even a wide string character, so that you can concatenate them. So these are the forms of valid forms of a cooked literal, and they always take precedence over a raw literal. A cooked literal says they can be unsigned long, okay, or unsigned or long double. The sign isn't even necessary because it's a unary prefix operator of an unsigned number. It can be applied inside the body of the operator, inside the body of the operator. It can also take, if you pass it a character string, then you have to tell it what the length of this character string is, so it knows when to stop eating up this character string. And it is possible to just pass in a raw char itself if you just want to pass in the W chars. All of this, as I said, is still runtime evaluation. Let me go over what raw literal means. Okay. So this is the sequence of characters in the original source plus the first 6 phases of translation. You can't get away with that. After the first 6 phases of translation, where they get macro expanded, string concatenated, you have still what's called a raw literal. Okay. This raw literal keeps all the significant information because once you get to a cooked form, a lot of information is lost. For instance, this 1.2 exponent minus 3 double float, decimal floating point float, decimal float, is not the same as 0.0012. This is the cooked form of 0.0012. You can't handle, if by the time you're given 0.0012, you can't put it back to the decimal floating point that you would want to keep it as. Okay? This is good for transforming the raw form of numerical floats and integers. Okay? And it's needed whenever the UDL suffix changes the meaning of the digits in the literal. When you're doing name lookup, the cooked form will always be looked up first before you looked up the raw form. Okay? And there's only a couple of things you can do here. Because it's a raw form, it can only take a const char star, or it can take a variadic templated version of this const char star. Okay? This is where the compile time evaluation comes in if you want to do embedded programming. Okay? You have to use this literal operator template. Okay? And and like any literal operator, like any template-embedded program, you have to use recursions to make it work. You do error checking through static assert, not throw for this case because it's a compile time one. The throw one will only work for the runtime one. Okay? And you have to use parameter packing and unpacking to make this work. Each time you unpack one digit or one of these raw digits, you do some calculation for some conversion on it. Then the next time you convert the next raw digit, and then you go on, recurse on and on. That's how you do that. Okay? I'm going to skip over the idioms and guideline because so I'm just going to close off with, because we are getting at 12:15 and people are hungry. I will close off with a couple of things about what literals do. So like I said, you can now use B. If it was designed using literal operators, user-defined literal, it would have looked something like this, where there's a binary version and an unsigned binary version. Okay. In C++ 14, fortunately, you can now use just a prefix instead. What we did in C++ 14 is we added the ability for certain literals, have them embedded in certain namespace called namespace std literal. And you can overload for operator S. S is now the suffix for, depending on what it is, it could be either a std string or a time duration. And some of this relates to some of the questions you're asking. Because the parameter in one case is a long double, in another case is not a long double. You know what the operator S, the suffix, is going to be applied to. So that way you can actually use the same suffix for either a string or second. Okay? I mentioned that StringView was trying to get the word for string, but they ended up getting SR or SV. Okay? We now have also supplied suffixes for hour, minute, all the usual chrono durations. And then lastly, we also supply suffixes for complex type literals like IL, L, and IF. There was some minor controversy with this one because we weren't sure if you put F in there as a suffix, it was going to be considered as part of the language of C++ if. After much thought, we realized that as long as it's right after the double quote, it will never be mistaken as an if, the opening of an if statement. So now it's all in C++ 14. And unfortunately, I have ran out of time. Okay. And I was going to talk about lambda closures. I'll leave this in the slides, how deductions work and how digits work. So yes, I did have a lot of talk. I could talk whole day. Yes. Thank you very much. I'm gonna let you guys off for lunch. Thank you.